Today we are learning about the carbon cycle. Please draw this diagram into your notebook. So we are going to start with what I'm going to call the core carbon cycle. This is part that you are probably already familiar with. So effectively, we know that plants are doing photosynthesis. So I've got my plants here, and then I've got my animals over here. Both the plants and the animals are part of the biosphere, meaning they're alive. Bio meaning living, and sphere meaning like the circle of life. So plants and animals are involved in this circle of life, part of the biosphere. Plants are doing photosynthesis, which means they take carbon dioxide out of the air, and we're focusing just on the carbon here because this is the carbon cycle. So they take the carbon out of the air using photosynthesis. The plants are also doing cellular respiration. Plants need to keep themselves alive, so they're doing some cellular respiration, putting carbon dioxide back into the atmosphere, but they're taking more carbon dioxide out of the atmosphere than they're putting back in because they're growing. So they're doing their own little carbon cycle here with photosynthesis and respiration. Some of the plants are being eaten by animals. So we've got eating here. All of the black lines are transfers. All of the pink things are carbon reservoirs. So the carbon is being transferred from plants to animals through eating, and then the animals are doing cellular respiration. And when the animals do cellular respiration, they put carbon dioxide back into the atmosphere. So the atmosphere is another carbon reservoir, and it's holding carbon in the form of carbon dioxide. It'll also have some other types of carbon, methane, maybe some carbon monoxide. So that is kind of our core carbon cycle. Then the plants and the animals eventually will die. And when they die, those plants and animals will decompose. So we'll see some death and decomposition from the animals and from the plants. And when they die and decompose, they'll go into the soil. That's part of the geosphere, which means it's part of the earth. So the soil is a form of or a carbon reservoir in the ground, gets there from death and decomposition from living things. The soil can then be compacted and turned into a longer-term storage, and that longer-term storage is called fossil fuels. So we call it fossil fuels because it came from plants, it came from animals, it got compacted, and it turns into this kind of like rock, like coal or oil, stored deep under the ground, and that's also part of the geosphere. It's part of the earth. So it goes from plants and animals, death and decomposition into the soil, soil compacted and stored as fossil fuels. In order to get the carbon out of those fossil fuels, well, naturally, there's not a whole lot of stuff that happens. Volcanoes can erupt. So if there's a volcano erupting, that's one way that we could get the carbon out of the ground because it'll spew a whole bunch of gases out of the ground. The big one is that humans dig up those fossil fuels and burn them. So we call that combustion because we're burning stuff. So the humans are now digging up these fossil fuels, taking them out of the ground, combusting them, burning them, and that puts the gas back into the atmosphere as carbon dioxide. So when we burn the fossil fuels, we're releasing the carbon as a gas. Carbon dioxide's the classic one. It could also be methane or some other carbon gases, but then it goes back into the atmosphere. All right, the other big carbon reservoir that we haven't yet talked about is the hydrosphere. And the hydrosphere is actually our biggest carbon reservoir. It holds the majority of the carbon in the world. So carbon dioxide can be taken out of the atmosphere and absorbed into the water. It's absorbed by the ocean, it's absorbed by lakes and rivers. Those lakes and rivers run down into the ocean, so eventually that carbon ends up in the ocean. That's part of the hydrosphere, hydro meaning water. And then that carbon also gets released out of the ocean back into the atmosphere. So we have carbon going into the ocean, we have carbon coming back out of the ocean. And then the carbon from the ocean can also sink down to the bottom of the ocean. It can become part of the bottom of the ocean, which I guess could be part of soil, and eventually it can get compacted and turned into fossil fuels as well. So that ocean can go over here, it can go over here. This is the carbon in the ocean transferring over. and then it can get dug back up and combusted, or it could get erupted in a volcanic eruption. I didn't have a volcanic eruption here, but that would be a form of combustion too. It's just a more natural form of combustion. It's not humans doing the digging up of the fossil fuels. It would be the Earth itself sending those fossil fuels back into the atmosphere as carbon dioxide. So that's our carbon cycle. We've got the core carbon cycle involving the biosphere and the atmosphere. That's probably the one that you're most familiar with: photosynthesis, eating, respiration. But then we've also got decomposition, compaction, turning into the geosphere. We've got combustion, taking it back into the atmosphere. We've got absorption and release into the hydrosphere, and back out of the hydrosphere into the atmosphere. Okay, so that's our big carbon cycle piece. Now I want to just add a few details about how much carbon is where and how much is actually transferring. So let's take a look at this image. So this image is showing with numbers. And these numbers are shown in gigatons of carbon, and then gigatons of carbon transferred per year. So the purple numbers are the transfers, and that's how many gigatons are being transferred. So gigatons is a bunch of carbon. Million tons or billion tons, I actually forget. No, it'd have to be billion tons. Yeah, mega is million, giga is billion. So we're talking about how many billions of tons of carbon, and a ton is 2,000 pounds, so it's a lot of carbon. All right, so let's take a look just at the black numbers first. This is how much is stored in these storage in gigatons of carbon. And you can see fossil fuels are holding about 4,000 gigatons. So there's a lot in fossil fuels. Of that, we're only digging up and burning a small amount of it, 5.5 gigatons per year, but that's still way more than otherwise would have been released. In the atmosphere, we have about 750 gigatons of carbon, and that's good because we need some carbon to serve as a greenhouse gas to trap some heat so that the Earth stays at a temperature where life can survive. But if we put too much carbon up here, we trap more heat, and that changes our climate. Vegetation holds about 610 gigatons. Animals aren't even listed on here, but soil, they are shown, but we basically are not a significant enough amount of gigatons of carbon to warrant being mentioned. The soils hold about 1,500 gigatons, and then you can see a ton of the gigatons, or actually many of, 38,000 of the gigatons, are held in the deep ocean. So the surface ocean holds about 1,000 gigatons, the deep ocean holds about 38,000 gigatons, and then ocean sediments 150. So most of the carbon on the Earth is held in the deep ocean. Some of it gets pulled down into the ground, pulled back up as fossil fuels, burned, and then we can look at our fluxes. So you can see it's a very small percentage that's actually doing the transferring. In and out of the oceans is 90 gigatons coming out, 92 gigatons being pulled in. Fossil fuels are releasing 5.5 gigatons out. Plants and soils are releasing 60 and 60 gigatons. I think this is, fires. Fires are releasing 1.6 gigatons per year, and then photosynthesis is pulling in 121.3 gigatons. And in here, 0.5 is coming into forests as well. All right, let's take a look at another example that has slightly different numbers, but gives you a similar idea. So this diagram is from NASA. Its numbers are slightly different, but in the same scale. So again, just looking at, these are all in gigatons. The atmosphere holds about 800 gigatons of carbon. Plants are holding about 550 gigatons of carbon. The soil is holding about 2,300 gigatons of carbon. Fossils and fossil fuels in the earth are holding 10,000 gigatons. Sediments in the ocean, 6,000 gigatons. The deep ocean, 37,000 gigatons. The surface ocean, 1,000 gigatons. So you can see the vast majority of carbon is held deep in the earth, or deep in the ocean. So most of the carbon is in deep storage. The amount that we're actually dealing with is 90 coming out of the ocean, 92 coming into the ocean, and that +2 indicates we're taking some extra carbon into the ocean, trying to store it in that surface or deep ocean. The ground, microbial respiration and decomposition, so it's bacteria putting out 60 through cellular respiration, plants putting out 60 through cellular respiration, photosynthesis taking in 123 gigatons of carbon, which means that the land overall is taking in 3 extra gigatons per year. The ocean is taking in 2 extra gigatons a year, but we are digging up and releasing 9 gigatons of fossil fuels, carbon. So that leads to 4 gigatons per year that we are adding to the atmosphere every year. And the reason that those numbers would be different is that the amount of fossil fuels we're digging up and burning varies depending on the year. Generally, as we have more and more people and we use more and more stuff, we are putting more and more carbon into the air. So this number is probably more accurate. We're adding 4 gigatons per year to our atmosphere, which has about 800 gigatons. So if you think about that for 100 years, that would add 400 to 800, so that's adding pretty significantly. That would be a 50% increase of the amount of carbon. And that would mean it's going to trap more heat from the sun, and that will lead to a slightly warmer surface temperature, or a significantly warmer surface temperature on the Earth. So that's our transfer of carbon through the carbon cycle. Great. So now you are going to use this carbon cycle information, and you're going to make a cartoon showing the transfer of carbon from atmosphere into plants, from plants into animals, from animals into the atmosphere, into the ocean, into fossil fuels, and then combustion back out. Enjoy, and I look forward to seeing what you creatively come up with.